I have you loud and clear.
Hello. Welcome. Science.
And that is to say,
physics,
medicine,
nature,
or
space, time,
the brain, life,
the universe.
This week, why are mountains pointy? Did dinosaurs live in large herds? And we have a giant snake, a few skulls, a couple of feet, and one of the oldest rocks on Earth here in the studio. It is Q&A time, and we're taking things right back to the very beginning. I'm Chris Smith, and this is The Naked Scientists.
The Naked Scientists podcast is powered by ukfast.co.uk.
Well, let's meet the panel of experts who are going to tackle your questions. Megan Strong is an Egyptologist. You're not as ancient as the rest of our panel. I mean that in the nicest possible way. Megan, what are we talking about when we're talking about the ancient Egyptians?
Yeah, it's not frequent that 2500 BC is the most modern person on the panel. But yeah, roughly that's the period that we're starting, 2600 BC, and then up to about 323 BC. So,
right, yeah. So about 4,000 to 5,000 years ago.
Yeah, absolutely.
A long old time. Thank you, Megan. Well, on the other side of the room is Lee Berger. Lee is from Wits University in Johannesburg, South Africa. He's not discovered one, but several, in fact, new species of ancient human ancestor. When do they date from, Lee?
Well, I'm going to run you from about 200,000 years back to about 2 million with Australopithecus sediba and Homo naledi.
So basically a potted history of where we all came from.
That's it.
And most people struggle to discover a jawbone or something in their lifetime career. You've managed to get basically whole skeletons of these things, and you have sitting on the desk with you some of them.
I brought a few of my friends with me.
Great to have you with us, Lee. Also here, Jason Head. Jason walks with reptiles and dinosaurs. He does that at the University of Cambridge's Department of Zoology. Jason, to help orientate people, when were the dinosaurs around?
So the oldest dinosaurs go back to about 240 to 245 million years. And of course, they're doing fine today with modern birds.
Which is good to hear. So we'll talk about dinosaurs with Jason later in the programme. And now way back in history, the oldest in terms of time on the planet, but not you personally, Owen Weller is a geologist from the University of Cambridge. What do you look at?
I study early Earth plate tectonic processes using the Natural Laboratory of Arctic Canada. And so I look at rocks that are as old as 3 billion years old. So I'm afraid I eclipse all of you here.
And how old is the Earth in total?
The Earth is 4.56 billion years. So we've still got another third of Earth history after that.
It's quite ancient, isn't it? Thank you, Owen. So all the questions relevant to geology and the ancient Earth will be going Owen's way. And as if the panel aren't already going to be put through their paces, taxed by your questions, we've got a little quiz for them coming up later in the show, and you can play along at home. Now, Megan, we've got something to kick off with for you, and that's all about hieroglyphics. Matt in Melbourne wants to know, how were hieroglyphics used in ancient Egypt? Was this the first form of writing, and what did they have against alphabets? And I see you have a very useful text in front of you because you've brought a dictionary.
I have, yes. So this is a very well-loved, well-used dictionary that was one of the first textbooks that I got as an Egyptology student and is sort of a Bible for me, really. Ancient Egyptian is a language that was written down, and hieroglyphs is one of the scripts that was used to record it. It is one of the oldest that we know of.
And when does it date from? Does it literally go right back to our earliest records of ancient Egypt?
So the earliest evidence that we have for simple hieroglyphs being used is probably about 3300 BC. And so that's quite a ways back. That's into the very, very beginnings of dynastic Egypt, but not up to the point of sort of pyramids, which is what most people think of.
And so Matt slightly provocatively said, what did the Egyptians have against alphabets and things? How do hieroglyphs work? Is it like Chinese characters where there are sounds, or how does it work?
Yeah, so hieroglyphs can work in several different ways. The Egyptians did have characters that could function as what we would recognize as an alphabet. So you can, spell out people's names, for example. That's very useful. But they could also stand for sounds. So something that we would think of as like a syllable. A single hieroglyph could stand in for that. Or you could also have hieroglyphs that would stand on their own as an individual object. So you could have a picture of a goose, and that would stand in for the word goose.
How did people decode them in the first place?
So most people will say that this goes back to Champollion, and the discovery of the Rosetta Stone, was the real sort of watershed moment. People had been working on the decipherment of hieroglyphs from the medieval period, but when the Rosetta Stone was found, that really allowed people to crack how you read hieroglyphs by comparing it to Greek.
So that gave, this is a Greek piece of text, this is the equivalent in hieroglyphs, and so people could begin to get some insights into how the language was constructed.
Exactly. So the Rosetta Stone is recorded. It has 3 different languages on it, one of them being Greek, one being Demotic, which is another script used to write ancient Egyptian, and then formal actual hieroglyphs.
So why did someone go to the trouble of writing that? What was the point? If these languages were around at the time and they could speak all of them, which they clearly could, why make that tablet?
Yeah, it's a good question. I mean, I think at the time the Rosetta Stone was found in the Nile Delta, and this was an area that was ruled by the Greeks at the time. And so Greek obviously being a language that they would recognize, but ancient Egyptian being the language of the country and still being used quite heavily for monumental inscriptions, which is what the Rosetta Stone was.
And can you read hieroglyphs now, thanks to your dictionary?
I can, yes, thank
Can
you,
you
dictionary.
really? So when you look at these
yeah.
these things, you can actually read it?
That is one of the cornerstones of Egyptology. You have to be able to read your hieroglyphs.
How long did it take you to learn?
Well, there's different phases of the language. So initially, to get your grounding takes a good solid year, and then you have to build up from there, different phases.
It's extraordinary to think that before you can actually begin to study something archaeological, you actually have to learn a whole new language in order to do that.
Yeah, absolutely. And sometimes multiple, depending on the period.
It's a good selection process, I suppose. It's only the fittest survive.
Those who are dedicated.
Darwin would approve.
Yeah, absolutely.
Thanks, Megan. Right, Lee, let's turn up the heat with this question, which came in from Colin on our forum.
Did our ancestors lose their fur about the same time they mastered fire?
What do you think?
Well, I think the first part is, what's the difference between fur and hair? We often speak of humans as having hair and animals as having fur, and the answer is nothing. It's the same thing. It's a semantic argument. But the sort of early part of our understanding of where we see a sort of fining and separation of hair in humans is probably at the root of that question. And we kind of tie it to 2 things. One is thermoregulation, the idea that we need sweat glands. We sweat our skin to actually lose heat. We believe that happened with long-distance walking and running and the sort of longer limb period generally associated with the origins of the genus Homo. So the answer is maybe it was associated with fire because those 2 things go back a very long way now. Fire, the oldest fire that we've got, is probably about 1.3 to 1.5 million years. It's surprisingly hard to see in the fossil record, but that morphology, that wider-chested, long-legged anatomy that signals sweat glands, maybe 2 million years, but, don't trust these dates these days. We keep finding something every other week that pushes something further back or in a different line.
We take for granted our access to fire in the modern era, but what would it have taken for ancient peoples, ancient ancestors of humans to have mastered the art of fire making and nurturing and using fire to good effect?
Well, having spent the last several years down a deep, dark hole looking at Homo naledi fossils, I've pondered fire a lot, and the idea of fire both as a heating source but also as a light source to move into these more remote underground chambers. Fire is a tricky thing. Most animals hate it. They hate it instinctively if you're a terrestrial animal for very obvious reasons. Fire is a very scary thing. At some point in our past, and that is somewhere in our very distant past, 1.5 million, 2 million, maybe, I would suspect even further than that, part of our family tree began catching fire. And catching fire is probably the first key to that. Manufacturing fire, we don't really have any evidence of until the last several 100,000 of years, and generally the early parts of that are controversial in and of themselves, because there's a big difference between catching fire in the wild after a lightning strike or some event like that, and then tending it for long periods, and manufacturing it. Anyone who's ever tried to use crude implements to actually manufacture fire would understand that there's a great technological leap and probably also a mental leap that may have occurred a little later in our timeline.
Indeed, someone who's tried to make a fire in a camp the traditional way, it takes quite a bit of dedication, doesn't it?
It's extraordinary.
There's a tweet here at Naked Scientist from Sarah Davey who wants to ask you, Owen, as a geologist, do you have a favourite rock?
I do. That rock's called a blue schist, and as the name suggests, it's a very vibrant blue colour. And not only are they very attractive to look at in the field, they're also very special rocks because they tell us that there was an ancient subduction zone at that locality. So that's where one plate goes underneath another.
What are they made of?
They're made of principally a mineral called glaucophane, and this has a very, very distinctive blue color, which gives it a very simple name, the blue schist.
I had a pet rock.
Go on.
Well, everyone who wants to get in geology has a pet rock when they're a kid. And so I had one. I lost it, though, and I've been sad ever since.
Oh, your life could have turned out very differently by the sounds of it.
Imagine what you could have been if you'd still got that pet rock today. So, Jason, interestingly, because Lee's saying about our ancient human ancestors losing their hair, but what about dinosaurs? What were they covered in? Because if you go to museums and things, you see many specimens of dinosaurs, and they show things with the skin a bit like a crocodile, but they're not exclusively like that, are they?
Well, that's actually a really interesting question, and there's a lot of research being done on this issue right now, and there's a lot of controversy. From certain parts of the geologic record, you have particular environments where you find fossils that actually preserve the impressions of soft tissues. With certain dinosaur groups, when we find those impressions, they often include integumentary structures that look kind of like hair. They're almost quill-shaped, and they're often called proto-feathers because they have kind of a feather-like appearance to them. And so right now there's a big question as to when do these protofeathers first show up in the history of dinosaurs? Is this a feature that all dinosaurs have primitively at the origin of the group? Or is this something that's evolved once or more than once very high up or higher up in these nested groups within dinosaurs? Certainly by the time we get to true birds, things like Archaeopteryx, then we see these well-developed flight feathers, and so we know what they're covered with. But whether or not T-Rex, for example, Tyrannosaurus, or any of these larger taxa would have had an overall covering, an integument of feathers or feather-like structures, it's a little more poorly understood. Amazingly, for some animals like Velociraptor, this small Maniraptoran that's risen to fame through the Jurassic Park films, we know they actually had probably elongate feathers running down the undersides of the arms because we found specimens that have feather quill spots on the bone.
So do you think that the dinosaurs could have evolved to have feathers in order to conquer new patches of the Earth, to access new bits of the Earth which would have previously been a bit cold for them, and having feathers enabled them to access and use those areas because as populations of dinosaurs and therefore competition went up in warmer spots, the choice spots were taken, so this enabled them to go into other further reaches because it gave them insulation?
It's possible, although the initial function for these feather-like structures is not 100% known. So they may have actually functioned as insulation for the animals, but also where we find them on these well-preserved specimens, they're actually quite patchy along the body. So they're not presented on the animals as being a complete covering to keep them warm. But these patchy distributions suggest that maybe what they were being used for was actually communication, that they could have actually had color cells in them, and they could have functioned as a form of display.
Thanks, Jason. Now, Owen, this question's coming from Paul. This is very geological. He wants to know why a mountain's pointy. What do you think?
Okay, that's actually a great question. So once you've had some kind of rock uplift, the shape or morphology of a mountain is simply controlled by the principal style of erosion at a particular locality. So to generate pointy peaks, or as they're more formally known, pyramidal peaks, you have the process whereby you have 3 or more glaciers which are diverging from a central point under the influence of gravity, and this leaves behind the pyramid. And this has given us such iconic peaks as the Matterhorn, Mont Blanc, Mount Everest. And conceptually, this is how most people view mountains. It's sort of in their mind's eye. They see these pyramids. However, I should point out that not all mountains are pointy.
I'm just saying, Lee's adopted homeland, of course, it's South Africa. If you go to Cape Town, you see a very famous flat-top mountain. It's called Table Mountain for an obvious reason.
Absolutely.
How did that happen?
It's wonderfully named. So Table Mountain is composed of flat-lying sedimentary rocks, and it's actually capped by a particularly resistant type of sedimentary rock called a quartzite. And so what happens here is that you get erosion that preferentially weathers out underneath the top-lying quartzite, which leads to sort of failure at the edges, so you get steep-sided cliffs and a flat-lying top.
And talking of pointy things and pyramidal in structure, of course, this is your bag, isn't it, Megan? How did they actually come up with the shape of the pyramids? What was their inspiration? Do we know?
Yeah, so the idea is in one particular creation myth of ancient Egypt, that Egypt evolved from this mound of earth that came up from this watery void of chaos called Nun. And this original mound of earth is thought to have been shaped similar to a pyramid. And so the idea is that pyramids are a way of recreating that original sort of mound of creation.
Thank you very much.
You're welcome.
Now, Jason, this question actually has been sent in by James, who was on our Facebook page.
Is it common to find different sets of dinosaur bones next to each other, or can you just assume that they're from one creature?
So, are they served up beautifully on a plate, one specimen, all in one place, easy to sort out, or is it a bit of a mess that you have to try and unpick?
Well, it's a bit of both, and it all has to do with physically where the animal dies and what are the various ways in which it actually enters into the rock record. So you have different kinds of what we call depositional environments. These are areas where the sediments that form the rocks the dinosaurs in are actually physically accumulate. And for some of these environments, you can have an animal effectively fall over, be completely buried, and then you have a very well preserved articulated skeleton. In terrestrial environments, more often than not, what you have is an animal will die, and then you'll have some kind of water action that takes the remains and actually transports them into basically a river system or a lake system. And in that case, yeah, you generally do find a jumble of bones from different dinosaurs or different animals. So you get a lot of disarticulation. You have different kinds of preservation as well, where certain bones will actually be exposed and weather on the surface before they then get transported and buried. So yes, it is very common. It's more common than not to find multiple types of dinosaur bones mixed in together.
Is that your experience, Lee?
Yeah, well, ours is a field where, particularly when we're looking for human ancestors, we find them one by one. Up until recently, the story of paleoanthropology was probably in excess of 90% of the entire record was made of isolated teeth or isolated small bone fragments. That's exactly the situation of an animal dying on the surface and going about the usual sort of processes in Africa or elsewhere where it's eaten or dragged apart and disintegrates. More recently, though, we've been very fortunate both on terrestrial deposits but also in these underground cave environments, finding more and more complete specimens. We have complete skeletons like the Littlefoot skeleton in South Africa, Ardipithecus, but we're starting finally to find deposits in more extreme, more protected environments where we have more and more complete specimens, and we're able to put individuals together. We can do like these hands I've got here. That hand was found curled up just like that, just in a death grip.
Lee is showing us, this is actually a replica, isn't it, of Homo naledi, your most recent specimen that you've uncovered at the Rising Star System near Johannesburg. And the amazing thing about the work that you're now doing is that unlike historically where you'd find a specimen like this and then you'd study it and it would be your sole preserve, now you're scanning these things and 3D printing them to produce a submillimeter precision thing a bit like that, which you can then share around the world, and a scientist anywhere could then begin to work on your specimen.
Not only can we do. If you go onto morphosource.org, you can actually download any of our fossils and actually 3D print them yourself in your local 3D printer in your library.
DIY Homo naledi.
Or home, and they are accurate up to just a few microns of the originals. And it doesn't have to be a scientist. In fact, the tens of thousands of downloads we're getting from school children are people who just want to have a hand.
Give you a hand as well. So, Megan, it wasn't just dinosaurs that got mixed up together. The Egyptians were pretty good at burying people. That's what the pyramids are all about, isn't it? Or was it?
Yeah, absolutely. And I have to add in that we have just the same amount of problems in Egypt of putting together complete mummies and skeletons as well, because the tombs have been lived in more recently, and even in ancient times, they were reused many, many times over. So you frequently have people that do not go together and bits and pieces of mummies that you can't quite figure out how many skeletons you have all in one tomb. Thankfully, with pyramids, they were intended to serve for one individual, particularly the king, sometimes queens. And they were primarily restricted to kings and queens of the Old Kingdom as well. So this is a very early period in ancient Egyptian history. So about 2600 to 2100 BC we're talking about. And they were intended to be the burial structures. This was their final resting place.
But they didn't just put themselves in there, did they? Because is it not the case that very often the other servants or other people who would have worked on the structure itself ended up being buried there too?
Not within the pyramid itself, no. So, for example, at Giza, there is the main three pyramids. Those were the ones designated for the kings. There are smaller pyramids. Those were for the queens. And then there's an entire separate cemetery for people who actually worked on building the pyramids themselves, that they had their own separate cemetery, their own graves, some of them more elaborate burials as well. But no, they weren't actually mixed in together in the same idea and the same place.
But were they voluntarily interred, or were they involuntarily interred? So having worked on the structures, was it sort of regarded as a real privilege for them to die alongside the person they were building the pyramid for?
Yeah, so it's not the same idea as servant sacrifice. So these workers, yes, they had incredibly hard back-breaking labor that they needed to be part of in order to build these structures. However, it was something that was well compensated. So you had living quarters while you were there. You were fed well. There's a fair amount of evidence that they had an incredible amount of meat that was brought into the site, bread, beer, which was their staple drink for the time. And there's even evidence that people who broke bones or even had traumatic brain injury, for example, they had surgeons on site to heal them.
Were they any good at brain surgery?
Well, they did actually live on a bit afterwards. There is some skeletal regrowth. There is some cranium regrowth. So, yeah, they did live for a bit.
I think, was it Imhotep was someone who actually documented one of the first linkages between what the brain does and the movement of the body. But I remember reading a text where I think it says if you put your finger through the hole in someone's head and stimulate the brain underneath, then the person shudders. And it's sort of linking the fact that the brain makes you move, because people didn't really know what the brain did historically at that time.
Yeah, well, the Egyptians didn't have very high regard for the brain. I mean, they'd discard it when you were mummifying somebody.
Through your nose.
Exactly. They would yank
Scoop
that
it out.
Yeah, you were dead when that happened, so that's good.
Well, you certainly were. Whether
you wanted to be or not, by that point, you were definitely dead. Yeah, but Imhotep, he was actually quite high regarded physician, priest, and is actually deified by the time you get to later periods because of his knowledge. So yeah, he was quite a famous person for his day.
So actually working on the pyramids was quite a privilege then. Megan, thank you very much.
Hello, Katie here with a quick request. The Naked Scientist survey is still open and we really want to hear your views. It's online at thenakedscientist.com/survey. It only takes a few minutes, and if you fill it in, you could win some Amazon vouchers. We read every word, so this is your chance to let us know what you think about the programme, or what you'd like to hear more of. That address again is www.thenakedscientist.com/survey. Thank you very much. Now, on with the show.
You're listening to The Naked Scientist with me, Chris Smith. And this week we have a panel of experts taking on your science questions. If you'd like to get in touch with the programme, you can email. It's chris@thenakedscientist.com. You can tweet @Naked Scientist. You can also find us on Facebook. Let's talk back to Lee Berger. You've got some guest interviewees on the table in front of us. There are two skulls either side of you, Lee, there.
One's an old friend, of course. One is the actual type specimen of Homo naledi from the Dinaledi chamber. This is the one that we announced almost 3 years ago, I guess. And we didn't know how old they were at the time, but it was the most complete skull that we had. Interestingly, if you're looking at this skull to describe it, it's a brown skull, but the white part in the front is the nose area we didn't have. These are some of the most fragile bones in the body, and they did not preserve in those early specimens that we were pulling out. So we kind of guessed at it. The rest of it all fit together, but we had to kind of guess at what the central face would look like. So we actually put a nose on there based on the way the face was angling down, and also the very advanced features we were seeing in some of the back parts of the skull. And I'm really pleased to say that we discovered a skull in another chamber, the Lassetti chamber, and we announced it about 4 months ago.
This is the same cave system. It's another chamber off of where you discovered these
about
specimens.
110 meters away, again, 40 meters deep, very inaccessible. We found a skeleton there that had a complete skull. This is the skull in AO. I'm holding that one now in front of us, and I'm pleased to say, after all that work, we got the face wrong in the original reconstructions. It's very clear when you see Neo's nose that it's much flatter, and when I hold them up together, you can see the difference in the reconstructions.
You hedged your bets a bit when you guessed, because you gave him a much more prominent nose, more towards what we would regard as humanish.
Or a Homo erectus-y kind of thing, and that was being led by some of the shape of the skull. It's clear, though, that Homo naledi, Neo's skull and face is much flatter, much more primitive.
Just to describe this for people at home, the actual skull vault is about a bit bigger than fist size, I'd say. So this would have been quite a small-headed individual. When would these have been running around on Earth? When do these date from, these specimens?
When I was on your show last, we said, well, they must be millions of years old. Every scientist was trying to guess at how old Homo naledi was based on the anatomy of the heads, of the body. There were several papers published saying it was 1.5 million, 2 million, maybe 2.5 million years old. We now know that this population of Homo naledi in the Dinaledi chamber is actually around 250,000 years old, between about 180,000 and about 340,000, with a central point around 250,000 years. That is really young. It's really kind of put a landmine in the middle of archaeology and paleoanthropology, because that sort of primitive ancient human relative should not have been alive at that point, according to what we'd been finding.
Megan was talking about the ancient Egyptians burying their dead. That's the striking thing about these individuals, isn't it? You found this in a cave system where really the only way they could have got those bodies into that cave system is that they took them there.
Our very controversial hypothesis that we put forward about 3 years ago was that the Dinaledi chamber was a deliberate body disposal site, that they came down this amazingly narrow chute entrance. It has enclosures 17.5 centimeters wide, say 7.5 inches wide, down 12 meters, which is 50 feet or so.
Because the job advert you put out for people to work on this project said, I want small, skinny women.
I didn't say women. I wanted skinny scientists.
It's the only job advert you can actually say these days legitimately and say, I want skinny people, isn't it?
That's right. And so we did hypothesize that they were deliberately disposing of the dead. That's not been disproved. It still sits as the most valid hypothesis. We now have, of course, not just one more chamber, the Lesedi chamber. We found another chamber. It just came out from underground about 4 weeks ago. Now, it's one thing when we talk about Egypt or other places and deliberate body disposal like that, but not with this brain. It's just very hard to fathom that they had that complexity, yet we're faced with it is what it is.
They're very small-brained, aren't they? If one looks at the inside of the skull, you can get some idea as to what bits of the brain might have been doing what and what the behaviour of an animal may have been, because it tells you about the size of the underlying brain. So if you look at these specimens, what does the brain look like?
Well, in fact, that paper's just about to come out.
Oh, damn.
And no, it's okay. I'll go ahead and break it.
For the naked scientist.
I'll give you the exclusive. It's very complex. Our scientist who's been studying our image of the brain that's pounded out on the inside of the skull all his life said, it's finally the brain I've been looking for my entire life, because it's very advanced. It's very complex, but it's tiny.
Did they have language? If you look, is there a swelling on the left-hand side, roughly where the language centre might be? Were they talking to each other?
Broca's area is enlarged in this. There's bilateral asymmetry. We don't know if they had language. I can tell you, though, if we are right about this sort of very complex behavior, it'd be very surprised if they did not have a language or a communication much more complex than any animal communication we know of.
So maybe not hieroglyphs, Megan, but they could have been saying something. Now, Jason, we've got this question which was sent in by Jack.
I want to know whether dinosaurs lived as a herd or on their own, and how do we know that? Thanks.
So, lonesome dinosaurs or sociable sauropods?
Yeah, so we know this from a couple of different lines of evidence for different dinosaur groups. We have trackway evidence that shows that groups like duck-billed dinosaurs and the large long-necked sauropods were moving in multiple age class groups. So you would have adults based on the size of their footprints and juveniles and babies based on the size of their footprints, moving in the same direction and also changing directions in the same pattern, in the same orientation, which suggests not only that the animals just weren't kind of going along the same direction, they were making the same turns, the same maneuvers. That suggests animals moving in the same direction, in the same grouping. We also have a few big monospecific bone beds, which are catastrophic events where you have a population of dinosaurs that is killed usually by something like a flooding event. Very famously, there's a group of horned dinosaurs called Centrosaurus from Alberta, and there is a mass death assemblage of these animals. So hundreds and hundreds of individuals in a single bone bed in a single horizon of rock, which really looks like a large herd of animals that was killed in a flash flood event. There are modern caribou mass death assemblages that are patterned just the same way that we see in these animals.
Absolutely amazing. It's incredible what you can infer from the footprints, isn't it? Well, that solves that one then. Jason, thanks. You're listening to The Naked Scientists, and I'm Chris Smith. This week we're answering the science questions that you have been sending in, and we've given the programme a very ancient slant because we're looking at old rocks, ancient human civilizations, the remains of ancient human ancestors, and dinosaurs. With me are Egyptologists Megan Strong, anthropologist Lee Berger, geologist Owen Weller, and paleontologist Jason Head. And if you'd like to ask a question for a Q&A show like this, you can get in touch. It's chris@thenakedscientist.com or tweet @nakedscientists. Now, it's quiz time. So, Team 1, that's Lee and Owen, are going to take on Team 2, Jason and Megan. So each team gets 3 questions, and if it's a draw, we have a tie break for you. So, Team 1, this is Lee and Owen. Your first question, true or false? So just tell me true or false, and you can confer, of course. Pirates wore eye patches so they can see in the dark. Is that science fact or science fiction?
I'm going to go false. How about you, Owen?
I think the eye patch was so that when they came out of the bottom deck, they could adjust their eyes to the light easier. I'm trying to think.
So you're going to say true?
I'm going to say true.
Oh, I got to go. They're ballast in the rocks.
Absolutely right. It sounds like a joke, but it's widely claimed they wore eye patches because they were covering over missing eyes. But actually they did this so they could see when they went below decks because they would still have one eye adjusted. Right, over to Megan and Jason. True or false? The ancient Greeks would get drunk after making an important decision. They'd know whether it was sound if they still felt the same way when they were drunk. Is that science fact or science fiction? What do you two think?
I kind of want that to be true.
Yeah, I know the Greeks like to drink.
What, today or historically?
Well, they have tons of stuff dealing with wine strainers, wine drinking cups, drunken wine drinking scenes.
And so much is written about the importance of wine and the philosophy behind wine, and so.
So what do
true?
you think?
I'm going to say true. Yeah, we're going to go with true.
Aww.
Boo!
I liked your logic, but it was actually the ancient Persians. A bit subtle this. They were from 550 to 330 before Common Era. According to the ancient Greek historian Herodotus, the ancient Persians had a ritual of intoxication. They believed that you could only tell the truth when you were drunk, so they drink a lot of wine after deciding on something, and if their minds still felt the decision was right when they were drunk, they considered it the right decision. I think you'd have to be drunk to come up with a rule like that, wouldn't you? Right, on to round 2. So it's Lee and Owen in the lead at the moment. Round 2, which is bigger? We want the larger of the two in this round, okay? Which is larger, the number of taste buds on a human tongue or the number of stone blocks that were used to build the giant pyramid? What do you think?
Taste buds.
I would
me.
go with
taste
buds.
We're gonna go with taste buds just because they're not that big of pyramids. And there's a void in them.
So you're going true or false?
We're going.
You're going the larger number is the taste buds.
The
larger number is the taste buds. Actually, it's not true. The pyramid wins. Did you know that, Megan?
Would have gone with taste buds.
Did you count the void? The new void they found?
The pyramid wins. We estimate more than 2 million stones were used to build the Great Pyramid. The number of that number is at least 100 times larger than the 10,000 or so taste buds on a human tongue. So not that many taste buds. So currently still in the lead, you two. But let's see, the other pair might equalise now. Question 4, Jason and Megan. What's larger, the distance from the surface of the Earth to the centre of the Earth, or the distance from the surface of the Earth to where the International Space Station is orbiting?
That's going to be distance from surface to center.
Yeah.
So greater distance would be the surface to the center.
Do you know how far it is?
I believe, isn't the diameter 5? Oh, no.
I'll give you
get this wrong. 5,000 plus kilometers, I believe, is the diameter, isn't it?
Not surprisingly, Owen has his hand up. What is the?
Can I get a bonus point for suggesting 6,371 kilometers?
It's about that's right.
Plus or minus. It's actually greater at the equator than the north.
It's about 6,000 kilometres from the planet's surface, although there is a bulge around the equator, making it slightly larger, between the surface of the Earth and the core or centre of the Earth. But it is only about 400 kilometres to where the International Space Station is orbiting. 1-1 so far. So here we go. On to the final round. Lee and Owen. What came first, Coca-Cola or Tyrannosaurus Rex? What do you think?
Well, they're going to refer to the name there, I presume. And so we've got Coca-Cola in late 19th century, right? Early 20th to 30th. And Tyrannosaurus Rex is going to be later than that, I guess, on naming. What's your thoughts, Owen?
I mean, it has to be a trick question, presumably. So.
Wait, no, we're not allowed to think like that. I'd go with Coca-Cola
You're going
earlier.
Coca-Cola, okay. You get a bing bong for that. The company was founded in 1892. The Tyrannosaurus Rex was given its name by Henry Fairfield Osborn, who was president of the American Museum of Natural History in 1905. So Coca-Cola has it. Right, so that's 2 to Lee and Owen. Megan and Jason currently on 1. Let's see if you're going for a tiebreaker. What came first, the discovery of the hole in the ozone layer or the first space shuttle launch?
Ooh. So I was going to say space shuttle, yeah.
Go with shuttle.
Yeah, you're competitive. I can feel the competition oozing out of Megan. That's right. Columbia blasted off for the first time in April 1981. The ozone hole was discovered. Does anyone know what year the ozone hole was discovered? It was actually 1984 by scientists at the British Antarctic Survey, Brian Gardner and his colleagues. They were actually in Cambridge, and they didn't make the discovery in Cambridge. Obviously, they went to Antarctica to make the discovery, but they were working here when they made that discovery. It led to the Montreal Protocol in 1986, the banning of chlorofluorocarbons in fridges and aerosols and things, and the ozone hole, which is currently Australia-sized, has stopped expanding. So we think that actually that was one of the most important interventions on environmental grounds we've yet made. Right, so that means we have a tie-break situation. So here we go with our tiebreaker. Whoever gets the closest answer to this one will win. Final question. When did the last woolly mammoths walk on Earth? Answer to the closest that I've got written down here. What do you all think?
About 18,000.
Is that what... I'm going to say something very different than that.
Okay, you guys ready?
Yeah.
I think so.
Okay,
yeah.
Okay. Well, let's start. We'll give Lee the chance first. What do you reckon?
I'll say about 3,500 years to 4,000 recent ones found
so
in
3,500 years ago or BC?
Oh, BC.
Okay, you're going to 3,500 BC. Okay, and let's go to the other team. Let's go to Megan and Jason. What do you think?
I thought it was about 4,000.
Yeah, that sounds right. Yeah.
So we have effectively the
one.
same answer.
Yeah.
Okay, actually, the answer is you're probably quite surprised. 1650 BC is the current evidence. Although most of the woolly mammoth population died out by 10,000 years ago, there was a small population of up to 1,000 woolly mammoths that were living on until 1650 BC. And to put it in context, as you will well know, Megan, the Egyptian pharaohs were midway through their empire, and it was about 1,000 years after the pyramids at Giza were built, while there were still woolly mammoths trotting around on Earth. So I think everyone gets a point. So we have actually a perfect solution that no one goes home any the wiser and any much a winner. So very well done to everyone there.
Everyone pretty much wants to be breeding tigers, and we do have to limit the number of recommendations we can give because there simply isn't the space to house all the potential tiger cubs there could be.
In this month's Naked Genetics, we take a trip to the zoo to find out how conservationists are preserving the genetic diversity of some of the world's most endangered species, from terrific tigers to tiny snails. Plus, our gene of the month is down the pub already. Listen and download now at nakedscientist.com/genetics.
You're listening to The Naked Scientists with me, Chris Smith. Still to come, the oldest evidence of the Earth's first mammals, and we hear about Egyptian mummification processes, plus a snake almost a metre in diameter. What does it eat? We'll find out. I want to go first, though, Owen, to you, because actually Sarah Davey, who tweeted at Naked Scientists about your pet rock, has now sent us a nice picture on Twitter of her pet rock. So thank you for that very much, Sarah. Mark in Bletchley has also got in touch and tweeted and said, great show this evening, make no bones about it. That's ideal. I want to ask you, though, about ageing rocks. This is from Lewis, Owen.
When you find a fossil or a rock, how do you work out how old it is?
Tell us about your rock, because you've got a rock there. How old is that?
It's not my favourite rock, but it is the world's oldest rock. So this is dated at 4.03 billion years ago. And to put that age into context, as I said before, the age of the Earth is 4.56 billion years ago. So it's the oldest rock. To date this rock, we need to do some form of radiometric dating. So this uses the principle that some elements are unstable and they will decay to stable isotopes.
So radioactive decay?
Correct.
Yeah.
With a known and constant decay rate. So if we can accurately measure the ratio of what they're called parent and daughter isotopes in a given sample using machines such as a mass spectrometer, then we can ascertain the age of the rock.
So just summarising then, you know that there are some, just by chance, there are some radioactive atoms in that piece of rock. And we know that radioactive atoms like that break down at a certain rate, which is a constant rate, and they turn into new types of atom. And if you count how many of each type are there, you get some idea as to how old or how much time must have elapsed, because we know how fast that process happens on average.
Yes, that's correct. There's actually many different radioactive decay schemes, so many different sort of pairs of elements that you might measure. But the most common one that we use is the decay of radioactive uranium to stable lead. And we most typically measure this in a very special mineral, which is called zircon. So although you probably don't realize it, zircon's present in many rocks, particularly granites around the world. And it has several extremely useful properties. So first of all, it's extremely durable, so it sort of can last for several billion years. And second of all, its structure really likes to take in uranium, but doesn't like lead. So when we find lead in its structure, we know that that's come from the decay of uranium in the structure from when that zircon formed or it was crystallized. So by measuring the ratio of uranium to lead in our zircon, we can say when the zircon, hence the rock, crystallized. And that's exactly what was done with this piece of rock that I brought in today, to say that it was 4 billion years old.
Lee.
So I just had a question to follow on, because as I was thinking the oldest rock on Earth, are there any fallen objects that are older than that are on Earth, like meteorites or moon rocks or whatever, that are actually older than that are on planet Earth now?
So you've caught me. I should have said the oldest terrestrial rock on Earth. You're quite correct. So we do have meteorites which do date back to the start of the Earth, so to 4.56 billion years old.
Where did they come from? Space, obviously, but what have they just rained in from the debris that formed the solar system in the first place at some point in Earth's history?
Yeah, absolutely. So there's a whole variety of different meteorites that we get. And the very oldest ones, they're a particular kind called chondrites or chondritic meteorites. And they've been really, really useful for telling us how the Earth formed, because we get some slightly younger types, which are then either formed of iron or they're formed of silicate minerals. And this tells us on the very early on in the Earth's history, we formed the Earth's iron core and the silicate exterior. So meteorites have been extremely useful for sort of probing these very, very early Earth planet formation.
Thank you very much, Owen. Turning to yourself, Megan, we've actually got a question from Gilad in Oxford, who says,
I recently read that there is a void in the Great Pyramid of Giza. Why is it there?
What do you think?
I think it's a bit early to say, but this comes from an article that was published last week in Nature. A Japanese team went into the Great Pyramid, the Pyramid of Khufu, which dates to about 2450 BC. They used muon particles, speaking of cosmic rays and other kinds of cool elements, but they used these in order to scan the interior of the pyramid to get a very accurate sense of where all the chambers are, etc. And in the midst of doing that, they discovered this previously unknown void, which rests above another vaulted space that was purposefully put there called the Grand Gallery, which is a ramped vaulted structure that leads up to the burial chamber of the king. And this void is above that. As for what it's for, I think it's still a bit too early to tell. There are other what are called relieving chambers, so spaces that were purposefully built into the pyramid to sort of take off the weight from these smaller internal structures. It may be something along those lines. It could be the remains of construction. Who knows?
Megan, thanks very much. Jason, got this question here from Georgia for you.
Dinosaurs were around for over 100 million years. Why did they achieve so little?
Did they really achieve so little?
I love this question so much because it allows us to actually probe a few things about how we think about dinosaurs. So dinosaurs get their start around the same time as mammal groups do. Where we are today, we have about 5,500 living species of mammals, and we're pretty impressive in terms of the diversity of sizes and ecologies that we do today. Dinosaurs today are somewhere between 10,000 and 18,000 living species, depending on how you measure species in modern birds. They have evolved intelligence. They do amazing things. They fly better than any mammal. And then if you think about the Mesozoic record of dinosaurs, they achieve giant sizes on land. They have an incredible diversity of behaviors, of body sizes and ecologies. So it's important to not think of dinosaurs as just being big lumbering things that lived in the past. They are one of the most successful and diverse groups of vertebrates in our history.
You've got a lump of one in front of you. That looks incredible. What's that?
This is actually not a dinosaur. This is better than a dinosaur. This is a cast of the vertebra of the giant snake Titanoboa. And so Titanoboa is a fossil snake related to modern boas and anacondas. And this animal occurred about 6 million years after the end of the Cretaceous, so after the end of the non-bird dinosaurs. And it was about 15 meters total length.
So how long ago is that dating from in millions of years?
We're looking about 58 to 60 million years ago.
Okay. Can you just describe so people at home can actually picture this in their minds?
Yeah, so this is Basically kind of a squarish vertebra with a ball and socket joint on it. It is about 5 to 6 centimeters wide and about 4 centimeters long.
I mean, it completely covers my hand. If you put it across the palm of my hand,
in the palm of your hand,
backbone bone is completely covering my hand. So that would have been along the spine of the snake, and the ribs would have opened up off of that and come round towards the front of the snake. What would have been the diameter of the snake's body then, where that was?
So this is one of about 300 probably vertebrae that would have composed the spine of the animal. And then the ribs coming off would have given the snake a diameter of about 1/2 to 3/4 of a meter.
Oof.
And the total weight of the animal would have been somewhere between 3/4 of a ton and 1.25 tons.
Goodness, what would it have eaten?
That is a really interesting question. It occupied an ecosystem with giant freshwater turtles, giant primitive crocodile relatives, giant lungfish, and the answer is whatever it wanted.
And it's a constrictor, so it would presumably have crept up on these things, grabbed them, and then inspiraled them, would it?
With a constriction force that no biological tissue could withstand. I cannot remember the number, but it is exponentially larger than the constriction force of boas and pythons today, and those animals are extremely powerful.
Lee?
I just love being a scientist, because only scientists would use the understatement of every time we find a big fossil, call it Titanoboa.
Of course.
I mean, that's just fantastic.
Well, the original name, my co-author, John Block, University of Florida, wanted to call it Tyrannoboa, and I told him no. I do also want to point out, this is important, Lee's specimens, the Homo specimens, you can actually see the scans of them at morphosource.org. Titanoboa is there as well. So if you'd actually like to see a 3D reconstruction of these vertebrae or download the data sets to print your own, that's where you should go.
Why did that organism become so big? Why is that not here today? Where's it gone?
So the hypothesis that we're working on is that the reason you can get snakes that large is that during this time period after the demise of the non-bird dinosaurs and what we call the Paleogene period of the Cenozoic, this is one of the warmest intervals in the history of Earth. You have no ice at the poles. You have incredibly warm oceans. You have tropical rainforests that are extending up toward high latitudes. You have crocodiles and palm trees at the poles. And with a what we used to call cold-blooded or a poikilothermic animal, we know that body size is going to be ultimately limited by the temperature within which it lives. And so what we're able to do is actually do the math to calculate how hot it would have to be to keep an animal this size alive. And so we were able to actually estimate temperatures for this interval in time. And they're consistent with a lot of other data. And so for our main hypothesis is that these animals got this big because the climate allowed them to do so.
Goodness, let's hope that doesn't happen again. Jason, thank you. Lee, back to you. This was posted on the Naked Scientists forum.
Did other ancient human species ever live together? Did they interbreed and did they fight?
You've sort of talked about this with your examples with Homo naledi and the fact that you have these animals, early human ancestors, however we might refer to them, putting bodies in a cave system. That argues they were cooperating or perhaps valuing their dead. But what about the other parts of the question?
I always love how questions like this always end with the sort of fight, the Neanderthal Fight Club kind of idea of human origins. Well, we certainly know that species have interacted in the past. Neanderthals are the best example of that, the best known. Not only did they interact, we don't have any evidence of violent interaction, and that we do have evidence of sex in the fact that many of us carry their DNA, a small part of Neanderthal DNA, usually somewhere in the 1.5 to 3.5 or 4% of DNA for Europeans or people from that area. There are others that we know that we interacted in similar ways with Denisovans, which are only known, in fact, from a finger bone that's now destroyed, to get ancient DNA out that we see some people on Earth sharing a small amount of DNA with them. There's a sort of mystery species X that was in Africa at about 200,000 to 300,000 years ago that interbred with modern humans, and we share some of that DNA. So we know that there were those type of exchanges that went on. What we didn't know were that some species like Homo naledi existed at the same time and place that modern humans did. Now, that's going to be a tricky question, though, right now, because we have two lines of evidence in the record. We have a fossil record, which is very, very poor and very, very rare. We have an archaeological record, which is rich and vast because it's made of stone. And so we see this sort of technological spread and cultural spread across these regions. And we have always, particularly in Africa, assumed that in the last 500,000 years or so that was all humans. It was large brain things. But suddenly you have things like Homo naledi popping up that are saying, whoa, wait a second, it's not that simple. Things didn't just go extinct. Humans and human relatives are a lot like other animals with existing lineages that went along. The hobbits on the island of Flores have shown us that. And I think we're going to see a whole lot more of that happening as we begin to open our minds and open up new areas, and begin to explore more. There's a lot more out there, a lot more mysteries to be solved.
Thank you, Lee. We're talking about a mystery that got solved. A big one was solved this week. There was a big announcement from the University of Portsmouth. This is for you, I suppose, Jason. Perhaps you can comment on this. That a student doing an undergraduate project was looking at some rock samples from the south coast of England and found these tiny teeth, which it was announced are the earliest evidence of mammals existing on the Earth, and they date to about 147 million years ago. Why does this matter?
Well, they're not the earliest mammals. There's a little bit of confusion. What's significant about these teeth is that they help us put down the divergence between placental mammals, so eutherian mammals, which are the people in this room, your cat, your dog, most of the diversity of living mammals, and marsupials, the metatherians, so your pouched mammals, your possums, your kangaroos, your wallabies. These are the oldest, we think, unambiguous at the moment, record of placental mammals. So there are all sorts of mammals that are much older. What this is it's a nice example of a pretty clear anatomical indicator that the divergence between marsupials from placental mammals had occurred basically by the beginning of the Cretaceous period, around 147 million.
The mammals that were around at that time were obviously in competition with the dinosaurs. Is that what kept them small? Because these were small animals, we think, weren't they? At least when these animals first evolved. Probably because they were continuously turning into lunch.
That's a generally accepted idea that basically the diversification of dinosaurs would have kind of inhibited the ability for mammals to radiate into new body sizes and new ecologies. And sure enough, after the end of the Cretaceous, fairly soon after the demise of the non-bird dinosaurs, you do see this big diversification, a flowering of modern mammal groups. It takes mammals a little while to get much bigger, actually. They don't really achieve giant sizes until fairly late in their history. But yeah, so for most of the Mesozoic, mammals are very small. They're probably nocturnal. They're fairly ecologically limited, although in mammals' defense, there is actually a dog-sized mammal that we know from the early Cretaceous of China called Rapenamammus, which actually has dinosaur remains in its gut.
Oh, right, so they did get their own back to a certain extent. You mentioned something interesting there when you said they were probably nocturnal. Is that sort of supposition of the fact that you've got something very hungry with big teeth running around during the day that had very good eyesight, a dinosaur? So if you came out during the day, you were more likely to turn into lunch. Therefore, these early mammals probably came out at night and they could tolerate the cold better because they were warm-blooded. Is that where you're coming from?
Actually, it has more to do with looking at behaviors in living mammals today. And one of the things that we can do is we can look at activity patterns across all of living mammalia, and we can actually reconstruct the ancestral activity pattern based on what we can see for all the living ones today. So if you look at 4 different groups of living mammals and you look at their relationships and they're all nocturnal, you can assume maybe their ancestors were nocturnal as well. So when that's been done for a huge number of species in mammals, what we actually find is that the most parsimonious solution is that mammals would have been primitively nocturnal. We also can see from the anatomy of their heads, their skulls, that these are small insectivorous animals with pretty decent-sized eyes. And based on both of those and comparisons with modern insectivores today, the most likely interpretation is that they were nocturnal.
So we're the unusual ones. Coming out during the daytime, we've evolved to become day active, when actually we're bucking the trend. Most of our mammalian ancestors would have been night active.
Most of mammal history is being small, nocturnal, and afraid of reptiles. It is after the Cretaceous, again, it's during this big flowering, this big diversification of mammals in the early Cenozoic that we definitely start to see really diurnal mammal ecology really develop.
Thanks for that, Jason. Well, moving on, here's one to shake things up for you, Owen. This is from Claire on Twitter, @NakedScientists.
What is a tectonic plate? Is the Earth unique in having them? And has it always had them?
What do you reckon?
Well, that's 3 questions in one, so I'll start with the first one. So a tectonic plate forms part of the outer, relatively cold and rigid part of the Earth that we call the lithosphere. And essentially, as you go into the Earth warms up quite quickly. And the effect of increased temperature on rock strength is to decrease rock strength. So the lithosphere is the relatively cool part, where rocks are relatively strong and relatively rigid. But as you enter the Earth, they become much weaker, and they can, in fact, flow on geological timescales. So this is flowing in a solid state. So tectonic plates and the lithosphere is just the strong outer layer, and below this sits what we call the asthenosphere. So the analogy is that tectonic plates are like icebergs, which are flowing on the asthenospheric mantle below.
Wegener had the idea that this might be happening more than 100 years ago, but it took quite a lot of data to emerge subsequently to prove that this was actually happening. What about the other part of that question, which was other planets? Is the Earth unique in having this geological activity, or do other planets appear to do the same thing?
So it's a great question because it's in fact an ongoing area of research. So certainly other planets show evidence for geological activity. For instance, we can see on satellite images of Venus that we have enormous volcanoes, and we can date the surfaces of planets by sort of how pockmarked they are. And so we can see that some planets are essentially being resurfaced by volcanism. However, what we don't see is the sort of geometric arrangement or jigsaw of tectonic plates that we observe on the Earth today. However, one really exciting new area of research is on one of the moons of Jupiter called Europa. And researchers there are suggesting that we do, in fact, have a sort of Earth-style plate tectonics where you have the creation and destruction of plates. But these plates are, in fact, made of ice. So we call this icy tectonics, and it's a sort of ongoing area of research.
So bottom line is you need what we have on the Earth, a squidgy interior with something fairly rigid on the outside and not too heavy to bob around on that squidgy interior. And that moves things and jockeys things around and remodels the surface. And so as long as you've got that sort of configuration, it doesn't really matter where it is or what it's made of, the same processes will play out.
Absolutely. It is a little bit of a Goldilocks situation where you need the right thermal profile and you need the right chemical properties. So, for example, Venus has a very similar size and thermal structure to the Earth, but it's thought that there's not quite enough water in the deeper parts of Venus such that it cannot flow. It's essentially too strong on geological timescales. Whereas on Earth, we have just enough water buried in the mantle, which allows these rocks to flow in the solid state.
So there you go. We knew Earth was just right. Now, Megan, we began with you, so we'll give you the final say. We have this lovely question from Caitlin, who wants to know,
what is the mummification process, and what is the best preserved mummy?
Megan, what do you think of that one?
So the mummification process is a means of artificially preserving the body. And the reason for that being is that the ancient Egyptians felt that they needed to have their body preserved intact in its entirety in order to have an afterlife. Now, for most people, that probably just involved being wrapped in a shroud or a reed mat to keep the elements off of you, or even just backfill from the grave that you were being put into. However, if you were wealthy enough, or if you were well connected to the king or something along those lines, you could have more of the Rolls-Royce treatment of mummification, which was incredibly detailed and took up to 70 days. Most people understand that they removed the internal organs, they would have preserved those separately in their own jars, and then the whole body would have been put into a bathtub or a vat basically filled of natron salt, which is a salt that is native to Egypt. And that would have completely desiccated the body so that you would have had this perfectly preserved human. Then that was anointed, wrapped in yards and yards of linen, and then you would have had your mummy. The best preserved mummy is either Ramses II, Ramses the Great, or his father, Seti I. And he was actually used as the stereotype for the mummy movies that Boris Karloff was in, so I think he looked pretty good.
So that's your favourite. That gets your vote.
Yeah, I think
Thank
I like
you
him
very
best.
much. Well, that is it for this week. Thank you very much to our guests this week, Megan Strong, Lee Berger, Jason Head and Owen Weller. The producer was Izzy Clark, and do join us at the same time next week when we'll be exploring some of the technologies that could revolutionise, we hope, the future of healthcare. The Naked Scientist comes to you from Cambridge University and is supported by the STFC, the EPSRC and Rolls-Royce. I'm Chris Smith, and thank you very much for listening. Until next time, goodbye.